DeepSeek's coding AI costs 14 cents. And if that's still too much, you don't have to pay it. They put the whole model on the internet for anyone to download without an account or a bill, which means they spent a fortune building it and then decided the correct price was nothing at all. So how far into the ground does the price of AI coding go when the company making it has already taken it to zero? When a company drops an AI pricing tier that looks like a typo, the immediate assumption is that you're looking at a launch promo designed to hook users before the real bill arrives. But if you look at the July 31st evaluation from Artificial Analysis, that 14-cent figure isn't a temporary discount because it carried over completely unchanged from the previous release. There is no trial window attached to this. You don't have to commit to a minimum spend, and there's no expiration date where the pumpkin turns back into a venture-backed startup and demands a real budget. You can pull up the side-by-side pricing tables and see that exact input figure listed plain as day, which confirms that as of right now, 14 cents is just the published standing rate. So the rock bottom price is completely real, and you're officially paying pennies for 1 million tokens of AI code generation, assuming the code you get for that price is actually worth using. Usually, when a company drops the price of inference this close to zero, you expect to get a lobotomized model that forgets its own name the moment you ask it to hold a complex thought. But according to the model's published specifications, V4 Flash natively handles a 1 million token input window, which means you can dump an entire codebase into your prompt without having to negotiate an enterprise contract. And you can see the DeepSeek V4 family doing real engineering work right there in the coding fleet comparison. Because when they test the larger Pro variant on SWE-bench to resolve real software issues, the results are right on the page. It clearly trails Claude Sonnet 5, which sits up at 63.2%, but it still hits 55.4% against that flagship. Proving that it can successfully resolve a majority of those issues shows that the 14-cent option is built on a serious engineering foundation rather than a budget lookalike, and it's doing it for a fraction of the cost. So if the model is this capable, and they're happy to give it away for pennies, you have to wonder what's stopping DeepSeek from charging you a whole lot more. Well, the thing keeping that price on the floor is that the published rate only applies if you rent their servers, and you always have the option to just bypass the toll booth completely. The model weights are sitting right out in the open on Hugging Face under an MIT license, which means running it yourself involves no account, no bill, and nobody to ask permission from, like a true off-the-grid prepper with a sticker price that bottoms out at nothing at all. And when you look at the underlying engineering that makes this tick, which Morph recently dug into, you realize this must have cost an absolute fortune in raw compute to train. Which leaves you with one obvious question. Because if a company burns a fortune building a world-class engineering tool, why on earth would they turn around and hand the entire thing out for free? So if you actually want to take them up on that offer and run the open weight version yourself, Morph's teardown of the model's internals estimates that holding the full 1 million token context window for just the cheap Flash variant at its compressed precision demands a single dedicated machine with 128 gigabytes of capacity. The files themselves cost nothing to download, but pulling down a repository is only the first step of the process, because keeping a model of this scale awake and actively chewing through your codebase requires constant uptime on physical hardware that never sleeps. Which means taking the free route simply pulls the cost off a monthly invoice and drops it squarely onto a physical box that you've got to somehow procure, power, and keep running on your own dime. And that leaves you with a very practical math problem. Because if choosing the free version means you inherit all of that hardware overhead yourself, is paying the 14 cents to let somebody else handle it actually the smarter move after all? The short answer is yes, because most of the model stays completely asleep while it works. On paper, the model carries 284 billion parameters in total, but it only wakes up about 13 billion of them for any given token. So when you ask it to fix a bug, the compute cost reflects only the specific pieces of the network that actually fire to answer you, while the rest of the architecture stays completely idle. If we look at Morph's teardown of the model's internals, you can see how this plays out on a single real request. Say you handed a Python script to refactor, and as the system processes your prompt, a router inside the network evaluates each word and only passes it to a small fraction of the layers. So a select few parts fire up to do the actual rewrite, while roughly 95% of the total weights literally never activate at all. That cheapness is built directly into the shape of the system itself, which means the low price is the result of raw engineering rather than a temporary corporate subsidy. Waking less of the model saves you compute on every step. But since reading long code files is the inherently expensive part of the job, what actually happens to your bill when you start dumping entire repositories into the prompt? When you dump an entire repository into a 1,000,000 token prompt, your bill is supposed to explode, because standard AI models have to mathematically compare every single word against every other word to understand what is going on. As the text gets longer, the math required to read it multiplies faster and faster, which usually means vendors have to charge higher prices just to cover the extra processing. But DeepSeek engineered their way out of that by changing how the model reads, starting with an approach whose lineage traces back to a 2025 DeepSeek paper on handling long contexts. What actually ships today is an evolution of that early research, where instead of forcing the network to evaluate every possible pairing, it uses a sparse-attention architecture that builds a compressed view of the context. So when you hand it a codebase, it doesn't map out how a variable in your database configuration relates to a completely disconnected CSS file. The cost of processing long code files was engineered down at the structural level, instead of just being subsidized on a pricing sheet. Which is great for the first pass, except an AI agent actively working on your codebase will end up reading those exact same files repeatedly as it loops through a problem. An AI coding agent reads your giant messy monorepo, writes a fix, breaks a test, and then has to reread that exact same pile of files to figure out what went wrong. If you had to pay the normal rate for every single pass of that trial and error cycle, your bill would add up incredibly fast. So the deepest discount on the board lands exactly on repetition. Artificial Analysis highlighted this in their July 31st write-up, showing that as of that date, when the model hits data it has already processed in the cache, the published rate drops by 98% to just fractions of a penny. That means the AI can reread the same unchanged context over and over, applying the discount to the precise thing coding agents actually spend their day doing. But if the initial read is only 14 cents and those repeat passes cost almost nothing, you're probably wondering how a real software job still manages to produce a bill worth arguing about. The catch here is that you don't actually go to the API to buy 1,000,000 tokens. You go to buy a finished pull request. And you are not the one who gets to decide how many tokens that takes. When you set an AI loose in your terminal to build a feature, it dictates its own loop. And Morph's technical write-up found that this model is unusually talkative. To pass the exact same coding benchmarks as the more expensive models, they measured it pouring out far more output than similar models need for the same run, which means it spends a lot of its own discount simply by talking to itself. Because that output is always billed by volume, a 98% discount on the price tag doesn't actually matter if the model just uses those savings to think out loud. So a per token discount does not automatically become a per job discount, because the task itself controls the meter. And if the final bill still grows the moment it makes contact with a real software job, that leaves open what else the rock bottom price failed to fix. Well, for one, it didn't fix reliability. In their July 31st write-up, measuring the cheap DeepSeek V4 Flash 0731 revision, Artificial Analysis tracked an 11-point drop in its hallucination rate. That metric specifically measures how it handles questions it doesn't know the answer to. And that drop only brought the rate down to 84%, while its raw accuracy stayed completely flat at 37% across the exact same update. Which means the newest version basically just bought caution rather than knowledge, because it answers wrongly less often without knowing more. And when you start feeding it whole code bases, nobody is publishing the retrieval benchmarks that would tell us if it can find a specific function buried deep inside a million token context window. You're left holding a model that's cheap to run, but missing some basic proof of precision, which leaves you wondering where a tool like this actually stands against the ones people still pay real money for. Because if you pull up BenchLM's actual SWE-bench verified leaderboard right now, you'll see that the highest ranks are completely locked down by expensive closed models. Claude Opus 5 currently sits in first place, and while you might expect a model this hyped to be right next to it, the free option is just not up there with them. That distance is a real gap rather than a rounding error, which tells us exactly where the open weights hit a very real ceiling. You're looking at a market where the free option only gets you so far, because at the very top of the board, money is still buying the last few points of performance. So if the absolute cheapest option isn't actually the best one, does that automatically make the most expensive model the right answer instead? We keep treating this whole market like a binary choice between the $0 floor and the absolute ceiling of the leaderboard, but that framing might actually just be a giant distraction. An analysis from LumiChats calls this entire matchup a false choice, pointing out that the sensible buy for a developer usually isn't either of those extremes. They argue that the real value sits right in the middle, because most of the day-to-day engineering work you do doesn't require the heavy-duty reasoning that the top tier charges a premium for, unless you're building something incredibly complex or you just really enjoy firing up a heavy terminal agent to center a div. And while a nearly free model runs autonomous loops overnight, you don't necessarily need that kind of scale when you're just sitting at your desk trying to debug a single component. Which means the giant price fight everyone keeps watching is basically a battle between two options that your daily workflow probably never touches. So if picking between the absolute cheapest and the most expensive models is the wrong frame entirely, what is the honest way to figure out what this actually costs? We already know the cost fractured into three separate pieces, landing first on the machine you have to keep powered, and second on the tokens you end up burning just to get a finished task out of a talkative model. And the third piece gets paid directly out of your own salary in the form of time, because you are now spending your day reviewing output that answers confidently but still needs its work checked constantly. Which naturally brings up the question of why a lab would spend a fortune building this thing if they aren't even charging for it. Well, giving away a highly capable model changes the market, because suddenly your rivals have to justify their own input rates to developers who know the alternative costs basically nothing. The invoice shrank in three separate places, and each of those places has an address that is not DeepSeek. So is 0 really the floor here? Or is there another number sitting underneath it? The sticker price for a capable coding AI finally hit absolute 0 because the weights were published and remain downloadable, which sets a floor that does not depend on anyone's pricing decisions. But when an invoice disappears completely, the underlying cost just changes address and moves straight into your office. Underneath that 0 sits the bare metal you have to buy or rent to hold the weights, along with the volume of output the model generates when a task gets complicated. Morph broke down the sparse-attention architecture, and separately observed that it tends to talk its way through problems, spending far more output to finish the same run. That means somebody still has to sift through all that output to find the working logic, because a giant context window doesn't review itself. And that somebody is you, which makes the absolute floor of AI coding the actual hours you spend checking the work. No matter how deeply artificial analysis tracks the price cuts on cache hits for a 1 million token block, human verification time does not take a discount. So the price of the model went to 0, while the price of the work held steady. And yet, stripping the API margin out of the equation is still the largest structural cut this tool has ever taken. Anyways, that's all folks.